All right, hello there. This is Garrett. Welcome to CL03 Data Streams. So we're going to be kind of going over this video and doing a tutorial and just jumping in and kind of keeping things as simple as we can, but obviously trying to dig deep down into the code as well. So data streams are basically, they allow client applications to publish name streamed of arbitrary structured data, which are added to recordings and are available for live visualization. Each entry in a single data stream is required to have a unique and always ascending timestamp. The entry data itself can be a Python type structure, such as a dictionary, tuple, list, integer float, or a NumPy array. The data stream entries are useful for storing changes to data over time. For example, you might store the X, Y position of a ball as it moves within a Pong simulation. The data, basically the data streams support, named attributes. Updates to an attribute replace earlier values for that attribute and are best used for metadata such as the current and eventually final score of a gameplay simulation. So just think of it as kind of like, hey, updating a spreadsheet or otherwise. So what we're going to do is we're going to go ahead and run this first code that you see right here, and we're going to dive into what exactly it does. So you could see down here, top level of recording view of file, attributes, spikes, stems, samples, and data streams. This is data streams. So data streams and recording is example data stream. Example stream attributes is right here. So the code that produces that is right here. As we have done before, we first start by importing the CL library. We import NumPy as well because it's very useful. And then what we're doing here is, again, with cl.open as neurons, create a named data stream by default. It will be added to any active or future recordings. Okay, so in general, what does that mean? Well, let's look into that code. Let's dive in here, and we do neurons create data stream right here, and then we name that data stream example data stream, and you can see that that is spit out down here, because we also log that to we print it, not a console log, but we print it down there, and we basically need to look here, and we see it with two attributes, which is a score and another attribute. So basically a little array, Python array down here. So an integer and an array is what we're putting in as the attributes. So this is super important, as we kind of go down and we're just like, hey, this is what our data stream is looking to kind of correlate with. Now, when we start the recording, we come down and, we declare recording, basically recording, neurons record, stop after 1 second. So we're making a 1 second capture. We grab the current time with neurons.timestamp. So, again, back into the previous tutorial, where we're getting the time, from here. And then from the CL package. And then we add some data stream entries with unique and ascending timestamps. So data stream.append timestamp. So we're taking the timestamp from here plus 0. And then we're giving, basically the, right here, we're giving the arbitrary data, we're putting that in. And, watch how we append the entries because, 4 times each with ascending timestamp plus 0, plus 1, plus 2, plus 3. And notice that there's a variety of data. So there's a dictionary, a list of strings, a plain string, so this is the plain string, and then finally a NumPy array of unsigned 64-bit integers. This shows off how flexible the streams really are, so there's a lot that you can do with these. And, when your agent goes and runs with them, you'll find, because that is something we kind of have to talk about nowadays is like, hey, your agent will go run off and probably, be using this if you're in the kind of world of data collection, and you will be. If you aren't, you will be very shortly, when it comes to this product, because it's super duper important that you look back. You can understand the health, being, what I've found is being good to your culture will be good to you. You have to be very, very pragmatic with your decisions that you make. in your code to respect the health of the obviously living organism, the iPSC neural culture that is behind these pixels that are pushing to you. So just a fun little note there. It is very important, though, this recording, and I've got some really interesting stuff kind of going on with this in my own personal research. Now, watch how we append entries and basically we come down here after we have done the appending of the entries, so we've done the append and we've set the attribute, updated a single attribute score with 1, and then in the data stream update attributes to score 2 and added a new attribute which is another integer 9.9, and then we end the recording here and just wait until it stops. So, when we come down here, that basically lets the recording finish, and then it opens the recording, so we have recording open right here. And, where we're getting to right here is basically the print statements at the bottom are able to kind of show us the final attributes that reflect our last updates. The score is 2 because it was updated right here. We can kind of see that. And the attribute writes the overwrite. So it's very important, very, very important stuff here. But when you come down, we've seen this one run, but the next one we're going to get into is the data stream view. So the HDF5 format does not natively provide for an intuitive way to store an index list of items where any item can be a different size. For this reason, data stream data is stored end to end simply in an array of bytes, and another HDF5 dataset is used to associate timestamps with indexes. So this is just an important nuance of, hey, when it comes to data structure, HDF5 format, HD5F. Yeah, I was saying that wrong. I just dyslexia there for a minute. But, or wait, HD5F, HDF5. Wow, no, I actually found a little typo bug. I think it's HDF5 is correct, but um, really, really going in deep here, to find that this has probably been there for 6 months. But we provide a data stream view class, which makes working with data streams comfortable. So right here, we're going to just run this, and we're going to go into, okay, what this is from, we're still, I believe, working with the previous data stream, so basically, we're looking at, to make life easy, that's why we have data stream, data stream view, so basically, you're able to essentially, right here, we're able to kind of overcome this shortcoming of, hey, like the HDF5 format doesn't natively provide a way. Well, okay, we have a way, in the recording view data streams. So we're able to, view it, and print it out here, the data stream as, hey, how many entries are in the data stream? Pull how many entries are in the data stream. If we come down here to number 9, I'm going to run number 9. And, here we're digging in to the actual data stream itself. For the timestamp, we're iterating from, in a for loop for timestamp data in data streams. So data in data stream dot items. So the items in there print the timestamp and the data. So we have timestamp data, timestamp data, timestamp data, timestamp data, and you'll see that corresponds with right here. So we go, I believe, dictionary. I think this one is, right here, we're coming in for an array, we're coming in for a string, and then we're coming in for a numpy array down here. So we're able to, kind of iterate through in that meaningful way, iterating over just timestamps, so it's that's what happens next here. I guess they all ran, so we can just kind of look over them. So we're iterating by only the timestamp, so there's no data. And then we're iterating just the data now, so you could see the the data. So again, we have this this first dictionary, then we have this array, and then we have this string, and then the numpy array. So some of this is kind of beating a dead horse, but we're in this one retrieved by using a timestamp as an index. So this is, just another form of, it's very similar to this right here, but we're using, the timestamp. I guess it would be important to look at how these two right here differ. So data equals data stream timestamp. So instead of just going, off of, all just, from the top, we're looking here into how it iterates it, as, using the timestamp exclusively, so this is very important stuff because basically, when we look at 11 and 12, we're basically fetching the bytes, we're using the start and end indexes, we slice that into data, and then, let me see here just to make sure. Yeah, so that's basically what we're doing in this one. And then when we come down to number 15, which is convenient that these all actually just ran, but we're dealing with something a little bit more complicated in this part, because it's like um, when we look at specifically this one, what we're doing is we're retrieving entries for a range of timestamps. So we're going for, timestamps, right here, we're declaring timestamps, second and last. So we're looking at, a range starting at the second timestamp and ending at the last timestamp. So for timestamp in data, data stream items for range, second timestamp and last timestamp, so we're putting it at position 1, and then we're putting it at position -1, to bring us to the last timestamp. And then we're printing out here, okay, you could see in chronological order, you could see how that all pans out. We range ending at the last timestamp +1. So, another very, interesting way you can manipulate data. You can retrieve the timestamps of just the data within a range. So here we're kind of setting a range. So in data stream, keys for range, second timestamp and last timestamp. Once again, dealing with kind of the same thing, which we've declared up there. And we're giving the data in those range of timestamps. Here, another for loop for data in data streams values for range, second timestamp and last timestamp +1. So this is again another way of iterating through the data from the second to the last. So if we scroll all the way back up here, we're going from this one +1, which is the second item, to the last, which is +3. So very, very, getting deep into this, there's a lot of different ways that you can, manipulate and, kind of wrangle data using your data streams and, retrieving just the timestamps or just the data. There's a couple more right there, but, we'll get into now the data stream attributes because this is, this is going to be really important. So the attributes, we'll just jump down right into this section, which is also already run. But just as the root group can have attributes, each data stream has its own attributes. Any custom attribute can be added to a data stream. So this is what we talked about at the beginning. You can add your own custom attributes to annotate your metadata, and this is something that we find really useful. With our products and what we're building is you kind of have to have this. So we'll see right here is we're dealing with a lot of print statements. Data stream, data_stream dot attributes print, and then the name of the data stream is data stream dot attributes name, and we you could see that down here, so that the name and then the value of the data is score, and you can see that right up there in attributes view, and actually I think it's down here is where it ends up printing out. And this is what it's pulling from. So it's printing the data stream attributes, and they actually don't print in order, like the same order that we're printing it down here. So you can print stuff. You can kind of, you can add other things in there, so it's super helpful to annotate and, create proprietary metadata structures that, benefit you and your organization. Now, when we're working with without data stream view, if you prefer, you can work with data directly with data stream within the HDF5 file. Each data stream has an index table data set that contains rows with a timestamp start index and an end index. So, timestamp, start index, end index. And in here, we're pulling the raw data stream, declaring that equals recording underscore view dot file dot root dot data stream dot example data stream, so that example data stream that we just printed, example data stream right here. We're dealing with basically, in this system, having an index table that contains those rows. And you can see in the code here, we're doing a for loop for, we're iterating through the data stream index for row in raw data stream dot index colon timestamp start index end index. So iterating in that cadence. And then we're going through row timestamp, row start index, row end index, and printing the list out here, so it iterates through that entire list. And basically, as a kind of housekeeping efficiency item, for efficiency, row 0, row 1, row 2 brackets, and in the brackets can be used instead of row timestamp. So row start index and row end index, start index and end index values specify which range of bytes from the data, data set are needed to access the data in the timestamp. So it's I'm not sure if key value pairs is the correct term here, but it's kind of similar to that. Is basically like, hey, I'm saying I want to, for, so that for loop, row in, and I'm pointing back to 19 there. For row in raw data stream index, we're iterating now. The difference is instead of timestamp, start index, and end index, we can go through 0, 1, 2. So 0, 1, 2. And you'll see here data in bytes. So we're printing it out in bytes. So that's a little bit different. We're using the bytes format here. And then as we keep going, the data is stored in MSGPAC in serialized form. And so we need to use MSGPAC to deserialize the data, because we're getting it back in bytes. We're getting it in byte data now. And to get it back in that format, we have to use the import MSGPAC and import MSGPAC underscore numpy. So print without MSG numpy for row in raw data stream dot index, timestamp, start index, end index, and then we're using the numbers 0, 1, 2. Data in bytes, raw underscore data underscore stream dot data, start underscore index, and end index. So we're going between the start and end index, so it already knows that, and then we're able to come down to data, MSGPAC dot unpack B, data bytes, and we can see that when we print this first one, so you get the without, and we can kind of see that there's a little bit of this byte data comes in a little bit goofy. It comes in like, hey, you typically don't really want to deal with byte data, the hex data like this. I mean, I know that there are some instances in a hex editor with assembly code that you do want to deal with byte data like that, but with MSGPAC underscore numpy, you can kind of see the difference here, because we can look at this object here, and we're looking, and the main difference is object hook, MSGPAC numpy decode, and MSG unpack. Actually, that's already here up here, so we're just unpacking it here, but in the second one, the difference is we're decoding it. So when it's decoded, you get nice little numbers, nice little taught in proper byte code there. And, I'm just going to say that that's a lot better. It's a lot more easy on the eye, because you could just see at the end, just iterating one number there. Whereas this is messy. It's, you're dealing with data shape, UA, all this stuff. And it's just, it comes down to like, maybe there's a case where you'd want to do it this way, but there's not many cases. In coding, and I don't even know if your agent was using it. It's probably going to always write it this way to decode. And I don't actually know. I think that there might be a way that it's like, I guess if you used a different package to decode, but I guess that's kind of as they say in the military, above my pay grade. So I think that the best way you could be doing this is right here. Making sure we're this example is to show the difference is in, the deserialized data and, the fact that you really do want that. But anyways, I think we've done a really good comprehensive tutorial here. I think we've showed a lot of really useful things for you and your organization. Again, my goal is to bring 1 million developers onto the platform of biological intelligence through the using data, So if you want to get in touch with me or you have any questions, my email is going to be in the description. And I would really invite you to just, hey, reach out, give me some ideas, give me some feedback, and let me know how I can help you onboard to either a real CL1 device with Cortical Labs, or if you prefer, you can use some of my data. We are specializing in just bringing people online with this technology, and we want to help you. And you can do it. Anybody can do this. Anybody can be a super scientist, researcher, and do things they never thought possible just due to, the advancements in AI. So if you're looking at this and you're maybe intimidated by the code, well, don't fret. There is, AI agents, but it's helpful to just look over this stuff and, really try to have an understanding at a high level of what's going on. And, you can see the CL1 unit over here kind of humming along. So I thank you, and once again, thank you and appreciate you watching this video. Have a wonderful rest of your morning, evening, or afternoon.